Hello, boss. Good evening. Website na make us bit me practice it. SQL also no or SQL also no any if you know w3schools .com so so bahano so many language computer programming languages are bit me I practice wahanum so to data side be near server side, which is where SQL war. So more JavaScript and different type of languages. I guess maybe a SQL tutorial to the same page way in my no. I usually prefer to do it this way because that way I can go through these one by one. So in this digital world, everything is based on data. So wherever you are, whichever industry, everything relies on data. So whether it's home office or the citizens of any country, that's data for you. If it's e-commerce, sending customers, that'll be data. Hospital patients, that's all data. So having the ability to query data or manipulate data is very important. So I say, and more. First things first. Let me see. Okay, see, so you scroll down, kakra. Let me try this one. So try it for yourself. So. Each of these pages now, it may take you time. So while we practice here, you can go through the pages and learn or see what they are trying to describe. What I say. So that's for you to do in your own time. But in terms of practice, these are all the tables in this example practice system. So these are all the database tables. Sorry, these are all the databases. Into your customer records, your categories, your employees, order details, orders, products, and so on. Now, what we're going to do is we're going to play with one of these with these databases. So, for example, in Trisu customers, usually, traditionally, the first thing you do with any database is try and access it or try and open it. So I mean, sure, when you guys were learning in class, but cover but I'll just quickly do a quick 5-10 minutes video, and that way when you're practicing yourself now, if you ever get stuck in with anything now, you can just make reference to the video and then see. So okay, maybe see if it will help. What I said. So. First on my mind, but it's very simple. Select everything. So select everything or select all from customers table, which is this one here. So we click run SQL, and then the results of what we've just asked for are here. So this is the customers table as a whole. So these are the columns and these are the rows. When we do this, we call this this bit now. It brings everything on that table, because what we're doing is we're selecting all from the customers table. So everything in that table needs to come back in the results, which is this lengthy table here. So that's the first one. You see, select. Now these ones, introduction, you don't need it. Syntax is basically, in a nutshell, if you're trying to, if you have, let's just say you have a series of queries and you only maybe just want to run one or two, so you don't want to run all of them, so you can do the syntax here, which is, if you do this one, if you do this one, that comments out this particular one, so it will run everything else but this one. So likewise, if you do the same for any of these, that means when it's running the query now, it will ignore these ones So that's the syntax. It will only bring the ones which are enabled. So what we've just done is we've disabled these calls. So so that's what the syntax does. The select we've just done, which is basically select from customers. Yeah. Okay. And then it returns 91 records, just like we did before. The second one is select distinct. So select distinct is basically saying that select a specific thing from that table. So if we do select from customers, it brings back everything from customers, but maybe we're just trying to find one particular record in here. So let's just say we're trying to find city, like this table. All these are just tables inside the database, inside the customers database. So in the customers database, we have customer ID table, we have customer name table, we have contact name, and then so on. So let's just say we want to just select a specific table from the customers database. Then we can do select distinct city from customers. So we just wanting just the city table from the customers database, right? Now here if we run these two, there will be a clash. I'm suspecting that there will be a clash. Yeah, it could not prepare the statement. So I've done this on purpose just to show you that the syntax now we touched on a few minutes ago can be used. So therefore we comment it out. So when it's running it will ignore this one and just run this one for me. So select distinct city from customers, and as you can see, it's only selected one particular thing in that entire database, which is just that table in that entire database. So that's that one. Now we can also comment this one and then uncomment that one there, and then bring back the table. So okay, now we're back here again. The next one is where. Okay, so here what we're trying to do is we're trying to select, select a scenario whereby we want to call a specific customer's information from the customer's database. So basically you want to call customer A, customer 1 from this database. So how we're going to approach this is now actually we can do select all from customers database where customer ID equals 1. So customer ID being the customer's ID being the primary key. So in each database we have one thing which we have one in any database we have one table which holds the primary keys. Kwame touched on primary keys. Primary keys are essentially basically one strong information that links every table in a database together, if that makes sense. So customer ID 1 would bring all this information about that customer, you see. So on this row here the most important table is the customer ID, because that table links, that table will supply you every information about that customer we need. So if you come back to our query now, we can say select everything from customers database where the customer's ID equals to 1. So that means that we are pulling everything from the database, the customer's database, where there's a customer who has the ID of 1. So if we run that, it tells us we've got the number of records that's come back is 1 record, because there's only one person with customer ID 1. So that person is here. We've got their name, their customer name, their contact name, their address, and then so on. So that's what the where statement does. If you're pulling exact information about somebody, we can do another one. So we can do say select all from customers where maybe where country like Germany. Germany. Now, when you're doing these countries, when you're doing these postal code countries, city, all of those things, now it requires you to have that word in here. So, like sometimes it can be substituted with equals to. So if you try equals to and it's not working, I try like, one of them should work. So in this case, let's just try like. So select everything from customers where the country equals or is like Germany. That means any customer who has a record, as in who is from Germany, should come up in our search. So as you can see, the number of records is 11. So because we're just looking for that keyword Germany, in this customers table, it's brought back everybody who is from Germany. You see, if we change it to, let's just do UK, it will bring the number of records which has the country set to UK. So that's that one. Now here it gets a bit complex. So the SQL and or not, right? Okay, so let me just write some and then I'll explain after. Yes, so SQL and or not. Okay, so with this one, you often say we could have a scenario like the first one, which is and. So select all from customers where city equals to London or London and country like UK. So where and would mean we want a number of things. We want a number of records to come back from our search. So with this one, so it doesn't like something here. It doesn't like, I'll say, okay, could not prepare a statement. The error is near equals to. Okay, so select all from customers where city like London and Tribune again, like repetition. Okay, so here we asking the database to return with entries where we have city like London and country like UK. So with that, it brings us everywhere London is registered and UK is registered. So we could change one of them for country like France. So it will bring us everywhere, every record with London as a city and country as France. No result. Actually, that's where or would come in. Yeah, if we did or, it will bring us both France and UK. Okay, so that's the end we've done. Or we've just done this now. So this one is a simple one. Select everything from customers database where we have city registered as London, or in that customer database, bring me everything where the country is registered as France. So we're asking them to return 2 records here, one with London as city and the other one with France, so as country. And as we can see, we have France and then we have London, France, London. So that's that one. Now the last one is not. So we can do select all from customers where we don't want a city like Paris to appear. So select all from customers where city not like Paris. See, so everything will come here, but it will not give us any city such as Paris. Yeah, so that's in a nutshell, that's what it is. In a normal working place now, these ones you will hardly be using them, but it's always good to know them as well. So then we move to this one, order by. Order by is just basically putting your results in order. So a simple one would be select everything from customers where so everything from customers, cool. 91 records are here. Now also usually it gives you these in ascending orders, so 1 to however many, but we could change it around. We could say we want everything, all the results to come back in a specific order. So we can do okay, order by city. So bring everything, but then put the city into an order, and then order by city ascendant. That means it will go from A, B, and then C. So A, B, and then so forth, C. Because we've done it by city, we could do it by customer ID. And it will do customer ID 1, 2, 3. We can do it by any of these tables, and then it will filter it that way. If you want to do it the other way around, that instead of doing ascendant, or even if you don't add the ascendant now, if you just run it now, automatically, by default it will bring you the ascendant. But if you add the ascendant, then it will also do that. The other one is descendant. So we're going in a descending order, which means the highest entry here, and then lowest. Likewise, if you're to do it by tower, it will be the highest, so that will be from Z, and then it will be back and forth Y, and then so on. So that's that one. Insert into this one is a bit tricky, so you would have to practice this one a bit more. So here now we are doing select all from customers. Okay, what we're trying to do is we're not trying to query the database anymore. We're trying to add data into the database, which is basically insert into. So insert into we'll do insert into customers. But here, one thing to make note of is that we want to insert everything into the customers database, but then we want to fill the tables in that database. So here it would be customer ID, same as this one, comma, customer name, contact name, address, city, postal code, country. Exactly how the tables appear in the database. So we are inserting into customers database, into these in that database we are inserting into these specific tables which are here. So that's what this call is for. Insert into customers, customer ID, whatever, and then we are inserting values. So these inside these tables are the values which are referenced here. Insert into customers, these tables these values. Okay, so same way now we've opened and closing parentheses. Now the first value here will be going under customer ID, which is this one. So we would give it a value, a number that hopefully doesn't exist here. So let's just put a random number as 678. So in here, create a new entry for me, give that person a customer ID of 678, but put it into quotes. And then we do comma, because we have a comma here. Customer name, let's just put test, or yeah, test Kwame. So that's the customer name we've put here. Again, comma. The next entry will be table contact name, contact example is that name for that contact we're going to give, comma, address, so address example, so and then comma, city, let's do Manchester. Okay, postal code, let's do M11 1FG. That's just an example again. And then lastly, country, let's do UK. And then we close. So what we've done here is we're inserting a new entry into the customer's database, but inside the customer database we want to write into customer ID table, customer name table, contact name table, address table, and so on. In these tables that we want to write into, we want to write these values, which is we are giving them a unique ID number, a customer name, which will go in here, a contact example, which is this one, address example, which is this one, city, postcode, UK. So that's just that. If you run this query, it should say you've made changes to the database row. To the database rows affected 1. So 1 row has been affected. So what we can do now is we can see if that actually works in reality. So we can do select everything from customers where, remember that where statement, because we're trying to specify the exact record in the customer's database, where customer ID equals 678. Sorry, 678. 678, just as it appears here. So when you run it, that's the entry we created here on this line, which we've just commented out. Customer, the test Kwame, contact example, one. So that's just basically that one there. It might take a while to get used to it, but it's once you understand it, it's very easy. So to go through them again, we don't need the null values. You hardly use those. We will need update, because you need to make changes or modify entries in a database. That's a common thing that can take place, whether it's changing someone's address, their telephone number, their contact number, anything really. You would need to update information on a customer, for example. So with this one, it's very simple. Update customers, which is update that customer table. If it was employees, you'd say update employees. So update that table. Let's just say we want to update this person, test Kwame. So update customers. In there, set whatever it is that we are updating. So set city, because we want to update Kwame city is wrong. We want to set Kwame to live in Leeds. So update the customers table. In there, set city to Leeds. But then whose entry is going to be updated to Leeds is Kwame. But Kwame, which is this contact name, customer name, is not a primary key. The primary key is this one, which was what I mentioned before at the beginning of the video, that the most important table in the database is always the primary key. So now in this one, the primary key is the customer ID. So update customers, set city to leads, where customer ID equals 678. So just come in the database, change the city to leads for that particular customer. Now it says you've made changes to the database. The rows affected is just one. So we can comment these out and then uncomment this one. So you see it's been updated to leads. So very simple. Okay. The next one is delete. The delete one, no, you might not really use it in many places because you know the permissions to delete entries or database entries, so that one will vary. Some companies will give you permission, other companies will just give you read-only access, but where you are given permission and you have to perform some deletes on some test data, it will be very simple. So you can say select everything from customers. No, actually, forget that one. Delete from customers where customer ID equals 678. So delete something from the customer's database, but in the customer's database, that something which you're going to delete has the primary key of 678. So that entry is 678. So delete this person from that database. And it should say, yeah, that worked. So delete from the table, the database where that table equals this. Now, if we then do select all from customers where customer ID equals 678, that number, that entry should no longer exist. See, no result. So that's just basically how that one is. This one, select top. On this machine it doesn't work, but that was basically saying, let's just say we have our database again, select from customers, right? So you could say select top 3 from customers. So give me the top 3 entries in that customer's database. That's all that's doing. So bring me the top 3 or top 4, top 5, top 10. So select all from customers, and then you can do order by customer ID. No. Okay, select top 3 star from customers. Then you can do order by customer ID descendant. So select the top 3 entries in customers and then give them to me in a descending order. So 3, 2, 1. Or we could do ascendant, so 1, 2, 3. But like I said, no, this thing doesn't work on this practice, select top. Yeah, select top 3 star. That's why it's select top 3 star from customers. So this is right anyway, but I know it doesn't work because I've tried it numerous times in the past and it's never worked. So these is the same as equal to. So we've done that already. Wildcards, I wouldn't worry about this for now, but anyway, let me just do it, then it's out of the way. Then you can save the video and make reference to it at a later date. Okay, So select all from customers. Right now, where the wildcard is, instead of writing the entire name, you can be lazy and do like a shortcut. So select everything from customers. Okay, so where you're calling this one here, Germany, the word Germany or Mexico, where country equals Mexico, but then the wildcard is this one here, the percentage sign. So instead of writing Mexico, we can just cut it short and bring Mex and a wildcard. So any entry in there that has the first 3 letters of Mex, it will bring it. Now in our table, no, that's Mexico. So if you run it at what is it saying? It's nothing. Okay, it prefers a like instead of equals. So everything that has Mexico, where in the country table, no, there's a star of MEX. So Mex. Likewise, no, if we change it to Germany, so let's just do Ger, then here it goes, Germany. That's what the wildcard is. That's just if you want to be quick and be lazy. So if you see something like this, you know, so they've just simply did a shortcut instead of writing the entire phrase. So you don't need to worry about in, you don't need to worry about in between. You can worry about alias. So that one is just basically, alias is, in simple and short, naming these tables. So maybe you want to change the name of the table to something else. Let's say you want to change city to town. So you can do select city as town from customers. So we no longer want city, we want to update city to town. That's why we do the alias and then change it to town. So if we run, there you go. So it's selected city as town from customers. In here you go, it's changed to town. So then if we do select all from customers, it's still brought back city, but I think you understand in a nutshell what I'm trying to describe here. So you can just change the name of the table temporarily if you prefer something else. And then the last one, which is important, is maybe joins. Joins work whereby you might have a number of databases, but then you want to join certain tables within database 1 and database 2. So a real life example would be Home Office 4 and Passport Office. So they work hand in hand with DVLA, which is the driving registration and license and so on, that office. So Home Office work hand in hand with them. Now, when you apply for a driving license or a provisional license, usually they will want to validate that ID, say it exists on the Home Office database, and then eventually they will probably want to join the information on these databases, 2 databases together, so their own and then the Home Office own. So that's when these things might be necessary. Or even in your own organization, they might have different databases and they might want you to merge them together. They might want you to merge a number of tables within separate databases together. I hope so you understand what I'm saying. If not, you can always ask, and then we can clarify it more. So here, all of these are individual databases. We have suppliers, we have shippers, we have products, but usually, we can join databases when they have the same table in them. So suppliers database, you will see say it has supplier ID in here, which again is a primary key. If you come to products tab, that supplier ID is still referenced here, again a primary key. So that means we can join these two tables together because they both share this primary key, this primary table or this important table in them, if that makes sense. So it's easier to join two tables if they both have they call it unique identifier. Now the unique identifier in this instance is this supplier ID here, because it exists here and it exists there. So it makes it easier for us to join the tables together. Now usually to join a table you'd have to start from one table and then you bring the other table to join it. So we are going to join products to suppliers. So what we do is select all from suppliers. We are now going to bring another table to join suppliers, and then the other way around. We're going to join products. So select everything from suppliers, join products table. Select everything from suppliers database, join products database. Okay. Now on suppliers database dot supplier ID. Now the dot supplier ID means when you come on suppliers database, which is here, in there's a supplier ID. So that's what the dot supplier ID means. Suppliers database, suppliers ID as a table inside the suppliers database. So on suppliers suppliers.supplier ID equals products dot supplier ID. Again, the products database has a table in there called supplier ID as well. So on suppliers database, pick the supplier ID table and then join it to products database, join it with products supplier ID in there. That way, because those two exist now, it allows us to combine and merge these two databases together. That's what I said. And so if we run it, then what you will find is it will join everything from those two databases, providing they have things that match. So so all of these are matching. They have matching information in these tables, so therefore it will join it together. So that supplier's ID, everything in there. If there's a supplier ID of 500 here and then there's a supplier ID of 500 here, it will merge it together and merge that information to become one. So that's join. Now there's something called inner join. Inner join means join only the information that exists on both. If that information exists here and also exists here, then join it. If the information exists here and it does not exist here, or it does not exist in anywhere, do not join them. So only join the ones that exist. So as you see, is reduce the numbers. Now all of these have been joined because they exist on both tables. What I said, that's what you call inner join. Left join means wherever these tables are, this might have been a left and that's a right, or that might have been a left and that's a right. So join from the left table to the right table. So if you run it, it would work. That means you're picking information from the left table or left database, and then you're joining it to the right database. You can do right join as well. I don't think right join works on this practice tool. So right join and full auto joins are currently not supported. So that's the right join. similar to the left join. No? You're moving information from the right table to the left table. Full outer join would mean say join everything, and everything, which means it could be in there or it could not be in there. It doesn't matter, just join it. So what I say, that's what that one means. Yeah, so in a nutshell, no, that's everything you need to know really. You don't need to know not much else in here. That one there later on, as you're comfortable with everything else, man, then you can take your time and go through these and learn them. Union is basically union allows tables to be added together as long as they have the same data type. So if it's integer or numbers are numbers. If it's numbers, that means numbers exist on table 1 and table 2. If it's characters are, and I say be a letters are, letters exist in both tables. That's when union allows you to join those two tables because it has the same data type. And then for the rest media, I would say just practice with the up here. Everything you do in the real working environment is stuff that I've just touched on or mentioned here. So I wouldn't really worry about the rest too much. It's not necessary for you to know the rest. If you know it, fine. If you don't know it, it's not a big deal. Nobody cares. Other people will know. So and then they can write a quick query for you. So don't worry about it too much.